Okay, ready?
Yeah. So, hi everyone, my name is Sarah, this is Elias, and the article we chose was titled Making Low Carbon Material Choices, and this is from the February 2001 issue. So, why did we find this article interesting? This article talks about the most commonly used materials in engineering, which are masonry, concrete, steel, and timber. And we found this very relevant to us because last year in our module structural design, we did a project on masonry, and at the moment in building materials, we're learning all about reinforced concrete. And we found this article interesting because it talks about sustainability, and it highlights how the most sustainable way to build a structure is to consider how it's going to be disassembled so these materials can be used again if needed to. So why is this interesting to the engineering profession? The main topic of the article is about reducing our carbon footprint, which is obviously important to help reduce the growth of climate change. And as structural engineers, we don't want the structures we build to contribute to climate change. And so low carbon materials have low embodied carbon in the production and transport. And this graphic shows all the different times throughout the construction of materials when carbon is produced, such as in the transport. And the main question this article highlights is which material is best for the situation and how can we use our materials most effectively.
Right, so to summarize what was actually in the article, the key output is there is no perfect material. You have to decide which material to use in which situation. To emphasize this, they had a table where they have different materials like wood, concrete, steel beams, and they have the same length, they have the same amount of embodied carbon, and they can hold up the same strength, but they differ in cross-sectional area and weight. So you would have to decide for your use which material to use. To give an example, small-scale structures usually work better when you use timber, but you couldn't build a big skyscraper out of timber, so their steel and concrete is more efficient. And then this article gave some hints on which material, how to use which material so it's used as efficient as possible. So for masonry, you want to reuse the bricks maybe later on, so you might not. You might use a mortar which is not as hard, so you can clean the bricks later and reuse them. For reinforced concrete, there's cement replacement, so you put less cement in. That helps with the emissions. For steel, there's like different steel options. We heard about that before in the other presentation. And yeah, for timber, you should use certified wood, which gets replanted, and you want to use local sources because transport makes up most of the carbon emission for timber. Yeah, there's like way more hints in the article, but we won't go through all of them. Yeah, and that's it. Question. It was so good, there are no questions. Yes?
So did you find, like, in your research, did you find, like, any material that they were, like, looking at that would be, like, ideal to, like, you know, be carbon efficient and be, like, used for, like, you know, big structures like skyscrapers?
As I said, it really depends on your situation, and for big scale structures, even though steel has like a lot of embodied carbon to it, it's still more efficient than if you were to use so much timber to hold the structure.
Yeah.
The question there is whether you should build those structures or not. Well done, very good presentation. I like that. Having graphics like that is really useful. Tables and as opposed to just photographs or like to speak from or speak to. works really well. Very good.